for our good friends who are away. Oh, by the way, I'm going to show you these algebraic ones where you're solving it with algebra. I know we got cut off last time. Alrighty.
She's like,
so I wanted to go over 3b real quick. It has an interesting result.
wait, D or B?
3b. How is it possible for f of 3 to be 5, but the limit as we approach 3 doesn't exist?
Wouldn't it be like a solid dot at 5?
Ooh, let's get that down. Yes. There's actually two ways to do this that I can think of. Two fundamental ways. So I like what May said, which is, doesn't this statement itself just mean that there's a point at 3, 5?
Yes.
So make sure you understand that. This statement is literally the same thing as saying the graph of the function has a point at 3 when x is 3, y is 5. So we have to have that, or the problem. That's an essential starting point to answer this question. So what kind of thing can be happening at 3 that would now make this statement true?
Wouldn't it just be a open dot?
So yeah,
Anywhere?
give me the name for this when it goes. Remember this? Does the limit exist?
No.
Well, yeah, this means the limit doesn't exist, and that's called a jump. So what if that's just what's happening here? So what if maybe it goes, who knows, something like that? They have to be.
If it's just the number, like it just can't approach it from both sides if the limit doesn't exist.
Yeah, if the limit doesn't exist.
Like it just can't be approaching it from both sides.
Right. So you couldn't have like. So a common wrong answer to this question would be like, let me make it bigger. A wrong answer would be, okay, here's 3, 5, and then here's a whole. This is wrong because,
That would be
That
3.
the limit would exist.
yeah, the limit at 3 exists, and it looks like it's maybe 3 or something. But like this limit exists. What we want is for the limit to not exist. Okay, now, here's. I mentioned this we covered this one yesterday at the other class, and I showed them this other way to do it, and a lot of them were like, "What? You can't do that." So that's why I wanted to show it to you, because I didn't think it would be controversial, but it was. So here's another way to solve it. What do you guys think about this? What's another way for the limit to not exist?
Have an asymptote?
Yes. What if there's a vertical asymptote?
And then a dot on 3, 5?
Yeah, you got it.
I did that on one of them.
Yeah, so what if my function does asymptote, something like that, and then we just put like a dot at 3, 5? Is that allowed? Yes. And then, so they were asking like, wait, how did that happen? How could you ever have a function that actually does that? Here's another example. What if you had a function like f of x?
Could you number H, letter H, but it's like that.
Leave that in a second. But consider this function. What if I said f of x equals 1 over x, but only if x isn't 0? But if x is 0, it'll be equal to like, I don't know, 4, some number. What that would look like would be the 1 over x function with a dot at 0, 4. And so look what I just did. What's the domain of this function now? All reals. Isn't that neato?
Wow.
So you can do that with functions. This is called we'll actually study these later. This is called a piecewise function. There's nothing stopping you from saying the function follows this rule if x is this kind of number, and it follows this rule if x is this other kind of number. Make sense?
Yeah.
Okay.
That sucks.
It do be hit different though, right?
It do
It do be.
It do be like that, right? Scooby Dooby Doo. We say 3h.
Yes, please.
Okay, so h says that how is it possible for the limit as x approaches 0 from the left to be 2. But the limit as we approach from the right doesn't even exist. So by the way, there's only one, actually I can't say this. As far as we are concerned, there's really only one way for this to even happen. How can the right side limit not exist?
You just don't draw it.
You just don't draw it. That's actually pretty interesting.
Is it just in an asymptote? Or could it be?
I do like what you said though. That's smart. Like if you said this, like here's my function. So as I approach 0 from the left, I'm approaching 2. What if the function just ended like that?
Yeah, why can't it?
Well, it does say make the graph have a domain of all reals if possible. So can we get a domain of all reals? Yeah, so.
Why can't you just start the line somewhere else?
What? Oh, we can't do this. We can't do like a jump again.
No.
Because then the limit from the right would exist. So what you gotta do is have some kind of like maybe an asymptote there. Like that. You guys see how the limit would be like negative infinity, which isn't a number?
Yeah.
So
Also,
now we can make the domain on rails that makes it a solid dot. So now I still have the limit as I approach 0 from the left is 2. That's y equals 2. Or it's the 0.02, I should say. And then this could be like say a natural log function that I put in there.
Is there a difference between like G and H where it's like limit and then there's an equal sign instead of and? Like is that gonna
G says that the limit as you approach 1 is equal to 4 and f of 1 is equal to 4. That's the way you could rewrite that. It says it says all 3 of those things are equal. That makes sense?
do it?
You'll figure that one out. All right, we're doing algebra 1s now. Algebra.
Algebra. I'm gonna reach out and grab you. That's a good song.
Is that from like Pittsburgh or something?
No, it's like by Steve Miller Band.
No. Okay. We covered the first 2 on number 4, right?
Yes. Yes, you did.
well, you said the answer to B, but I don't remember it.
It was 0.
So B might make more sense after we covered this one. Because this one might look a little like challenging or whatever, but this is actually extremely easy. This will be one of the easiest ones we cover because if I were to graph this, where is the funky behavior happening? What x value?
5.
At 5, right? The vertical asymptote. So you know what? I'll describe. You don't have to graph these, but it helps if you have at least. You need to have some general idea of like, well, if I were to graph this, there'd be a vertical asymptote at 5, and it would end up looking something like this. So this is a hard one to draw because the x-intercept's -5, but looks something like that. But what I really want to focus on is, well, what if I want to talk about the limit as we approach 3, though? Is this even like a difficult question to answer if the function's continuous here? You know what I'm talking about?
Wait, so how do you? So
What if
how?
let's rephrase the question. Aren't I really just asking what's the y value of the graph when x is 3?
So do you plug in 3 then for x?
Yep, you just plug in 3. Plug in 3, you get 3 plus 5 over 3 minus 5, which is 8 over -2, which is -4. So there's a moral to the story here, which is,
Pay attention in class, kids.
well, sure, but the moral of the story here is if you can plug this number into the expression without anything funky happening, then you're done. That's it. That's the answer.
So like D would be funky.
Right. So that'll be the more interesting one.
It just
But-
doesn't exist, right?
But no, we gotta we'll cover that one at great length. Don't worry. But the first three questions on here they're there for a reason. So when we had this one earlier, this is actually reciprocal. Now, does that maybe clarify things why this one is just 0?
Yeah, because it's 0.
Yeah, your first step on a limit is always just plug the number in. Because if you plug the number in and you get 0 divided by 10, well, 0 divided by 10 is just 0. There's nothing funny happening there, right? Nothing weird. So this is just 0. However, on problem A, when we went limit of x plus 2 over x minus 2, when I plug in a 2 there, what do I get? 4 over 0.
So
That's
can't
funky,
exist.
right? Yeah, 4 divided by 0. What that tells you, though, so your logical process is that tells me there's a vertical asymptote on this function, and I know that at vertical asymptotes, the limit does not exist. Okay, so we're all cool with that?
Yes.
All right, so if you spaced out, here's one more time. Your first step 1 is always just take that number and plug it in. If you get a number, if a number comes out, you're done. Okay? Notice that is not a number. That's undefined. That is a number. That's 0. That is a number. It's -4. Okay, now D is where it gets interesting. Let's ask this question. Some philosophical question for you.
Doesn't it just equal
What is 0 divided by 0?
0?
No. No.
It doesn't exist.
That's a better answer.
Infinity.
If I just ask you in a vacuum, what is 0 divided by 0? The answer to that is it's an undefined quantity. Undefined. In a vacuum, what I mean with no context. I just straight up say, what is 0 divided by 0 with no additional context. The best answer you can give to that question is it's undefined.
If you have 0 friends and 0 cookies, and you
Yeah.
try to give 0 of your cookies to 0 of your friends, how many cookies do your friends have?
Exactly, yeah. That's a good example of why it's undefined. Because if I have, when I say 10 divided by 2, I got 10 cookies, and I'm giving 2 people, each person gets 5
I
cookies.
thought you were gonna say 4.
Or I have 10 bananas, and I want to put them into 2 piles. How many bananas are in each pile? 5, that kind of thing, right? Or I have 10 bananas, and I want to put them into piles of 2. How many piles will there be? 5. So division makes sense. But if I have 10 bananas, how can I put them into 0 piles? That question doesn't really make sense. You can't divide those. Even more so if it's 0 bananas and 0 piles. Doesn't really make sense. Right. So the question, now you can get into more rigorous, reasons why you can't divide by 0. I think I've talked about it before, but 10 divided by 2 is 5 because 10 equals 5 times 2. So if 10 divided by 0 equaled a number, then 10 would equal that number times 0, which is not possible. Although that does raise interesting questions about, well, then couldn't this be possible? Because this makes sense? That actually does make sense there.
Yeah.
So anyway, that might give you maybe something to think about in this context, which is, what's the limit as x approaches 4 of x minus 4 over, okay. What happens if I plug in 4? What do I get?
0 over 0.
You get 0 over 0. Now, this is a limit though. Do I actually care what happens when x is precisely the number 4? No, I do not. What I care about is what would happen if x was 3.999 or 4.001. That's what I really care about. So this is actually a special name for this. It's called indeterminate. In the context of a limit, I mean. So what we'd say is that this limit has an indeterminate form, okay? And all that you gotta know is, to solve them is, I gotta do more stuff. I need to investigate further, okay? So someone take a shot at this. What do you think I'm gonna do?
Find the x or y intercept. Find the y-intercept.
It's not a bad answer, but
No.
that's not it. What do you think I might do with this thing here?
Asymptote. Split it up.
Factor it, yeah. Let's factor the bottom. x minus 4 times x plus 4. And the top was, I'm gonna write it like this, 1 times x minus 4. Cool beans?
So then you cross it out.
So now this is the trick here, is this still a problem if x is exactly 4? Yeah, if x is exactly 4, then I'd have 0 divided by 0. But again, we're taking a limit. Technically, we're only caring about numbers very close to 4. So I can divide these out. And now I have the limit, as x approaches 4, of 1 over x plus 4. Now, what should we try now? Anyone?
Plugging 4.
Yeah, let's go back to our first step, right? What's our first step always on a limit? I see a limit, I go, can I plug a 4 in? Can I just plug the number in? So let's plug the number in. You get 1 over 4 plus 4, which is 1/8. That's the answer, 1/8. Isn't that a weird answer?
It makes sense.
In this particular context, now I'm not saying that 0 divided by 0 is equal to 1/8 or anything, but in a certain kind of funny way it is. For this particular function,
So that would mean that the y-intercept would be at 1/8, right? Or am I just,
there'd be a hole there.
or a whole? Yeah.
So if you want to think about this graphically, what's happening is, if I wanted to graph this, I would graph that function. So it would be 1 over x plus 4 with a hole at 4/1/8. So now does that graph picture agree with our graphical understanding of limits? Maybe?
So,
Can we do
I think I
e?
just need to think about it.
Oh, are you messing with me, Paige?
No,
Because I would agree with you. I sincerely would agree with you that yes, it might not make sense right away, but there's a connection here between. Remember when we talked about holes? We, graphed them and stuff. Okay, so this ties right into that. This question could have been phrased: find the y value of the hole that exists on this function. That could have been maybe the way it. But this is saying the same thing pretty much. So. Do you guys see how the procedure is the same? It's the exact same algebra steps. And if I were to graph this, I'd have the limit existing. Let's do one more. And we'll be done. Let's look at E. So E is, E says, what's the limit as x approaches 3 of x squared minus 9 over x minus 3? Plug in 3, what do you get? Yeah? Indeterminate form? So what will we do? Back to the top, yep. I've got x plus 3 times x minus 3. That's nice. We get a little bit of cancely-wancely action. This time the remaining term is on top. So now I've got the limit as x approaches 3 of just x plus 3. So what's the answer?
it would be 6.
6.
Can you do h?
You can do it. Just factor the top and
Well,
bottom, right?
so once it gets factored though, there's like 2 different equations. So then wouldn't it just be like, it would end up being like x plus 5 over x plus 3, and then from there you just plug it in and.
Yeah, you still plug in 2.
Oh,
You
okay.
plug in 2 in the everywhere you see an x, it's left over.
That makes sense.
Um,
So for I, it would just be 0.
so there you go. That's it. That's how you calculate a limit algebraically. So most of them are like that. There's a couple of weird ones. down the road. Next week, we'll talk about the end behavior ones, where x is approaching infinity.
So what page?